Alright, I have some questions about worksheet 9.1. This is about arc length, and so I thought I'd go through that real quick. Okay, so this thing starts off, find the measure of each arc in circle B. So just going through, this is 180, JIH is 180, JI is 151, so HI must be 29. And you can see this central angle is 90 degrees, so GJ has got to be 90 degrees, which means GH has to be 90 as well because JGH is 180. Alright, so now we have all of our arcs, so we can go ahead and start filling this out. I'm going to go through this rather quickly because we've already talked about this a bit. HIJ is 180. GJI is 90 plus 151, so that's 241. GHI is 90 plus 29, or 119. GJH, oh, that's all the way around except for 90, so that's 270. HGJ, okay, that's 180. GH is 90. GHI, we already did that one, didn't we? Oh, did I do one wrong? Well, hopefully you caught one I did wrong. Maybe it was, which one did I do? GHJ, oh, I'm sorry, GHJ, this is actually 270. GHJ is 270. Read that wrong. GHI is 119. HJI, well, HJI is 360 minus 29, so that's 331. JHI has got to be this way, 180 plus 29, so that's 209. And JIG is 270. Okay, just a little review of arc measures. Alright, moving on. Find the circumference of each circle. Remember, circumference is circumference. We can either say C equals pi times diameter, or C equals 2 pi r. I just prefer to convert radius to diameter and be done with it. So if the radius is 16, the diameter is 32, so my circumference is 32 pi. Much easier. Number 14, we have the diameter of 22, so our circumference is simply 22 pi. And that's meters, and this is inches. And we have to double this, which is 12 times 2, or excuse me, 6.8 is 13.6, so our circumference is 13.6 pi. And it said leave it in terms of pi. Okay, we found the circumference first because now we're going to find the find the length of each darkened arc. We find the length, that's a distance. Okay, real quickly, what I want to do is talk about the difference between arc measure and arc length. Okay, if we take a circle with a radius of 1 inch. Okay, it's not going to be perfect. I want to do this quickly. Let's try that again. That's a circle with a radius of 1 inch. Okay. And now we double it, and we'll say a circle with a radius of 2 inches. Okay, same center. Okay. So the circumference of the smaller circle is diameter of 2, so 2 pi. And the circumference of the bigger circle has a radius of 1, 2, so a diameter of 4, so it's 4 pi. So the distance around the circle is twice as big. Okay? Now if we drew, let's do this with a ruler here. And you have to trust me that this is 90 degrees, or take my word for it. Okay, this is a 90-degree central angle, which means this arc measure is 90 degrees, and this arc measure is 90 degrees as well. So you think the travel around one circle of a clock or a wheel, it's 360 degrees. So we would say that it is 360 degrees around this circle, and hopefully you would agree that it's 360 degrees around this circle as well. But you would have to agree that this arc measure is 90 degrees and this arc measure is 90 degrees because they're both 1/4 of their respective circles. But you would have to agree that this distance is not as long as this distance. So arc measures are the same, but arc lengths are different. The bigger the radius or the bigger the diameter, the bigger the arc length. Length and measure. Make sure you understand the difference. Okay, so now we're ready to talk about arc length. Arc length. Okay? And remember, arc length is simply let's write it over here. Arc length equals the circumference of a circle times the arc measure over 360. So basically the circumference of the circle times the fraction of the circle we're talking about. Okay, so let's go. C equals, well, pi times diameter, or 18 pi. And we're talking about 1/20th of a circle. Okay, so the arc length is 18 pi times 120 over 360, which hopefully we realize that is 1/3 of a circle. So 18 pi times 120 goes into 120 once, and 120 goes into 360 3 times. And 18 pi divided by 3, we get an arc length of 6 pi. And we're supposed to leave it in terms of pi. All right, and this is inches. So let's see what we got here. So the arc length, we'll just put it right in this time. The circumference, okay, that is a diameter of 18. So we'll say 18 pi times 180 minus 30, or 150 over 360. And again, we can just put this right into our calculator. So it's 18 pi times 150 over 360, and we get out of there and get 15 pi over 2. And that's a perfectly legitimate answer. I'd be happy with that, but some of you guys prefer to write it as 7.5 pi, which is fine, and that is feet. All right, number 18. So we have the arc length is, well, this is the radius, so it's 40 pi when we convert it to diameter, times 315 over 360, the fraction of the circle. Oops, let's get a little bit out of. Okay, so let's put that in our calculator. That's 40 pi times 315 over 360, and we get 35 pi. So the arc length is 35 pi, and that is meters. Okay, moving on. Let's see, number 19 has a diameter of 24 inches. You can always tell diameter because they put it right over the center of the circle. Diameters will always be put right over the center, where you can see up here the radius is put over the middle of the radius. Okay, so we have arc length equals 24 pi. Oops. 24 pi. Hopefully you can remember that's 24 pi. And that's 270 over 360. So arc length equals 24 pi. And 270 is 3/4 of the circle. So 24 goes, 4 goes into 24 once, excuse me, 4 goes into 4 once, and 4 goes into 24 6 times. So we get an arc length of 18 pi. All right, so we can tell this is half a circle, right? 180 over 360. So our arc length is simply 16.4 pi times 1/2, which means our arc length is 8.2 pi. All right, well, this is 60, which means this is 60, which means this is 60, which means this is 60 degrees. So our arc length is, this is a radius, so 30 pi times 60 over 360. We've already reduced this once. We have an arc length of 30 pi times 1/6. 60 goes into 60 once, and 60 goes into 366 times, which means we have an arc length of 6 goes into 6 once, 6 goes into 35 times, so we have an arc length of 5 pi, and that is feet. Don't forget your units, which I do quite often. I'm not a good math teacher. Okay, let's continue on to the back. Let's see here. Is that really where we go? I guess so. Oh yeah, that's perfect. 21, 22. Okay, here we go. Number 22. In circle B, the length of ST is 3 pi. Okay, so we have a circle B, and the measure of ST is 120. What is the radius of B? Okay, so let's see. The length of ST, so we're just going to call S and T. We really don't know what we do know. Let's see. The length of ST is 3 pi. That's a distance. Okay. And the measure of ST is 120. What is the radius? So let's plug in what we know. So arc length, okay, equals, remember, it's pi times diameter times the arc measure over 360. So let's figure out what we know. We know the arc length is 3 pi. We know there's a pi here. We don't know what the diameter is. We do know the arc is 120 over 360. Arc length, they told us, I plugged that in, and arc measure 120. So let's see if we can simplify this a little bit. We have pi times diameter here still. We're going to have to convert that to radius because they asked for the radius, but we'll do that at the end. 120 over 360 is 1/3, so we can actually say pi times diameter divided by 3. Alright, so let's get rid of those pi's. We don't need those pi's, one on each side. And let's multiply both sides by 3. So 3 times 3 is 9. And 3, those go away. So we end up with a diameter of 9, which means our radius will equal 4.5. Alright, let's just check out and make sure that works. Let's see. So if we have a radius of 4.5, arc length equals, remember, it is the circumference of the circle, so pi times diameter, which is 9 pi times 120 over 360, which means arc length equals 9 pi times 1/3, and 9 divided by 3, we get an arc length of 3 pi. And that's exactly what they told us. Okay, moving on to number 23. Okay, well, we've already done this worksheet, haven't we? We did 23 and 24 on another worksheet. It was on 12 point, what are we working on here? It was on 12.4. I just went over that one on the back of 12.4. That's another video. I'm not going to redo those. Let's see, I think 25 is a new one. The marching band has ordered a banner with its logo. The logo is a circle with a 45-degree central angle. If the diameter of the circle is 3 feet, what is the length of the major arc? Okay, so what we're talking about here, we got a logo with a central angle. Let's say it goes here. Okay, and a central angle of 45 degrees. That's not too bad. If the diameter of the circle is 3 feet, and say we'll put a diameter in there of 3 feet, what is the length of the major arc? So we want this length right. Oh no, the major arc. So we want to go this way. The major arc, remember, is a long way around. Okay, so they want this distance here. The major arc. Okay, let's make that nice and dark so we remember. Marching band has ordered a banner with its logo. The logo is a circle with a 45-degree angle. Central angle, if the diameter of the circle is 3 feet, what is the length of the major arc to the nearest 1/10? Okay, so the arc length equals 3 pi. That's the circumference of the whole circle. 3 pi times diameter, or 3 pi times 315. That's 360 minus 45, because we want the major arc, everything but that 45, over 360. I think we've already done this one somewhere along the way. Let's get our calculator out. So we go 3 pi times 315 over 360, and we get 21 pi over 8. Hit that arrow button and we get 8.24, or 8.2, and that is feet, I believe. Okay, I hope that clears up any questions you had on worksheet 9.1. Let me know if you have any other questions.